we're doing this. Yeah, so Ivan spoke a lot about Java and how it is or it is not relevant. Good news, this talk has nothing to do with Java at all. So I don't know if it's a good thing or a bad thing, but we're going to talk about AI-assisted engineering and AI-assisted code, which works with every language. And some people claim that considering what the networks inferred or learned from, it'll probably do better on other code bases, not necessarily Java, like Python and JavaScript and TypeScript. But what I'm going to present you works in Java as well. So we're going to talk about how we shouldn't trust a monkey. We're going to talk about the Chasm, the craft, and the chain of the AI-assisted code. So we have a problem of trust, especially trusting code that generates by AI, for a very good reason. Since AI-generated code became all the rage a couple of years ago, there was done a lot of research about the quality of AI-generated code, and it's not great. So you can see one of the research done a couple of years ago actually said that 65, 46, and 31%, which globally much more than half of the time, the code the generated code is just wrong. This is a new research from a couple of months ago, and it basically says that there is a measurement of how good a model is in writing code. It's called pass at 1. And every new model that is released by this company or another always brags how their model is now better on this performance metric. And the folks that did this research found that there is absolutely no correlation between how well the model performs on this metric and the quality of code that it generates in terms of number of bugs and code quality and everything else. This is another very interesting research done by Kodo that measured two things. Hallucinations, basically code quality, and our confidence when it comes to shipping code with AI. And you can see here that 76% is in this quadrant, which is a combination of very high hallucinations and very low confidence in shipping AI code. And just to show of hands, who agrees that the AI-generated code hallucinates a lot and we cannot trust it? Here we go, 76%, right? Right on the money.
0.4? 0.4?
Well, it's kind of hard to do the 0.4 here. Yeah. Stack Overflow, they kind of anti-AI biased for obvious reasons. Well, not they, but the people who are still in Stack Overflow, probably not the biggest fans of AI-generated code. So take this with a grain of salt, but here you can see that between highly distrust and someone distrust, we are way past 50%. The majority of people distrust AI code. What else here? Yeah, this is a very interesting metric. It's called code churn. This basically measures what percentage of code will be thrown away in a short term, I think 3 months. And you can see here how since AI started to write code, this number skyrockets. So basically the code that AI generates will be thrown away very, very soon. This does not necessarily mean that this code is bad. It means that it's disposable for multiple reasons, but it's also like an interesting data point. Security is a huge concern when it comes for AI-generated code. Again, a research from a couple of years ago found that 40% of the code generated has security vulnerabilities. And this again from a couple of months ago, critical severe issues such as hard-coded passwords, path traversal vulnerabilities will observe in multiple models. This is another interesting research from API IRO. This is API, like basically payment data credit card numbers in the code base. And you can see how it skyrockets as more code generated. API missing input validation and authorization. Again, like a spike because of, not because we cannot assume causation, but definitely correlation. In the age of AI, you can see how it goes all the way up. Yeah, and asking AI to fix problems created by AI goes exactly as you might expect. Generate correct code and then fix itself, something that it cannot do. Repair buggy code and self-verify whether bugs are resolved, it's something that cannot do. And explanations for incorrectly generated code and repairs, it's something that it cannot do. Well, again, if you ever tried it, you know exactly what those researchers are talking about. My name is Baruch Sadogurski. I'm at jbaruch everywhere on the internet, head of developer relations at TaxCare. Now, if what I just showed you about the state of code in 2025 made you reluctant about upgrading to the latest versions, and you would prefer to stay maybe on the older versions of APIs and frameworks, talk to me. We will make sure that you get the most secure versions even after the original supporters stop providing their support. I have tons of t-shirts to give away for good questions, good conversations, for you being here, being nice, and participating. Java Champion wrote a couple of books about releasing software, DevOps tools for Java developers, and Liquid Software. The most important slide of this talk is this. If you go to speaking.jbaruch, or there is also another URL that I will show you in a second, you'll find all the slides already there, the video that I'm recording, and that's a good reminder to check that I am. Yes, I am. Very cool. And all the links, including all the research that I mentioned previously, but not only, everything else is there. It's on the bottom of every slide. As I promised, there is like another URL, shownotes.taxcare.com, that you go there. And there is a QR code that you can scan. If you are doing it, I will let you a couple of seconds to do that. All right. OK. So let's go back to and think about how the software starts. It usually starts with something like that. Software design document, or software definition document, or some kind of document that explains what this software should be about. It's usually written, most of the time, it's written by non-technical people, product people, business people, you name it. And they usually explain their intent of what the software should be in text. This software should do such and such, introduction, system overview, design consideration, and what's not. Now, the problem with software design document is that they are write once and read maybe once. If they are boring, probably less than once. And the question is why? Why we as software developers are not really married to those software design documents and not like love them as much as the people who wrote them think that we should love them? And there are a number of reasons. First of all, there is a lot of misunderstanding going on. And we think that we speak the same language, but not really. Now, bear with me here. I'm going to try a New Zealand joke. I'm not sure it will work, and we will see. Did you get what I wanted to say here? No. Well, I tried. So what I tried to say, there is a saying, bring a plate, which basically in New Zealand, that means you should bring a dish. And then people who are not from New Zealand come with empty plates because they've been told to come with a plate. Well, sorry, I tried. Well, yeah, so what I try to say here, that even if we do nominally speak the same language, English, it's not really the same language. So that's might be part of the problem. The other really big problem is the curse of knowledge. I don't know if you had this experience, but sometimes when I went to university and I get into the class and then the professor starts with some overview, like this is what we're going to talk about, and I'm kind of lose my concentration for a second because it's just an intro, and then like 30 seconds later I look at the blackboard and it looks like that. And I'm like, what happened? What did I miss? One of the problems that caused the curse of knowledge. The curse of knowledge is when we understand something, we think that it's very obvious. Because we understood it, it sits well in our head, it's pretty clear to us, and we assume that because it's clear to us, it's clear to everybody else. And that's a very large reason for people assuming that other people know stuff and understand stuff and can understand stuff. And really good teachers know the problem of curse of knowledge and know how to battle it, but other people who are not trained to spot it might miss it. And when we speak about our interaction with non-technical people in our organization, a lot of those people, most of those people, never think about stuff like curse of knowledge. So they have assumptions that they have in their head that they assume that you have them in your head, and you are not. So it's a specialized type of lack of context. So why they don't work? Human misunderstanding, including curse of knowledge and other context misunderstanding. Context is not shared enough. Stuff that they know, they assume that you know, but you don't. And vague responsibility boundaries. Software definition document speaks about what should happen in software, but not really who is in charge of make this thing happen. This is a very old picture that I hope is not relevant anymore in the world of IT in 2025. It used to be the thing when there was this animosity between the developer and the tester. Anyone thinks that it's still an issue now? No, because it's not. Because we as software developers want to write high quality code, and we understand that QA people and testers are here to help us and make our life easier. Next iteration of this war was between the developers and ops. If you remember, there was a thing before DevOps when there was developers who drew their work kind of over the fence and went home at 5 p.m., leaving the ops people to deploy the scrap during nights and sit on outages and what's not. This is also kind of not a thing anymore because DevOps kind of sort of solved it. But this is real. This is not going anywhere. The animosity between technical people and product and business people in general, it's still very, very in effect because of what we spoke about, and especially because of the vague boundaries on who decides on what and who does what. Right, so those software documents are landing in our lap, and we expect it to do whatever it's there when the context is not clear and all the problems that we spoke about. So basically, we have a trust problem not only with AI. The whole idea of us not knowing what to do and the product people not trusting us to do the right thing brings exactly the same problem. We have a trust issue, but not only with AI. Next thing you know, this is how our software looks in 2025, and that's a Venn diagram. And I bet the majority of you agree. Think about software that you like and software that you know really, really well. It's probably different software. Except of Groovy, maybe. Right, okay. But we do have working software sometimes. Like occasionally, on occasion, we have working software. How that happens? That happens because a lot of overpowering the gap that we spoke about. Right, first of all, good intentions. Both business people, product people, and technical people want working software and want to have a good relationship. The animosity, the lack of trust is not something that anyone desires. So we can overcome that with good intentions. We will take responsibility, we will ask questions. The business and product people will also make an effort to make sure they overcome the curse of knowledge. So there is a lot of good intentions going on. Professionalism. We take pride of software that we produce. So when we know that there is a problem with software quality, we will try to fix it because this is our job. Tests and QA help obviously a lot when it comes to quality. During the entire process, we have those guide rails that are built in to help us create software that eventually works. And result observation, right? We'll look at the software that we produce and we can decide if it's not good enough, we need to work more on it, and what's not. Eventually, we do have common-ish context. So there is a lot of context that is going missing. But in the end of the day, we work in the same organization on the same product. And we all have more or less understanding of what we want to achieve in the end, how the end result should look like, what are the technical and non-technical considerations, and all this kind of stuff. Now, welcome to the era of code generated by AI. There is no such thing as intentions with AI-generated code. There is no such thing as professionalism because it's just like a neural model. Tests and QA are not existing or written after to fit the code that it's already there. There is no end result observation because it spills the code and says, well, this code should work, right? It doesn't check the end result. And there is obviously no context because it doesn't know anything about what it tries to achieve. So our software is not great, but we are trying. AI doesn't even try. And this is what I call the intent to prompt chasm. It looks like this. We ask something from AI, and the AI doesn't understand entirely what we are talking about. Because it's a stupid neural network. It doesn't know what we are asking. And of course, this is like a hyperbole and exaggeration. And obviously, the model, especially the programming, know exactly what Spring Boot is. But you get the idea. It lacks context. It doesn't know what we are trying to achieve. And this is exactly the problem. Now, it gets worse. The problem with neural networks and AI and code in AI is that it's a stochastic system. It's non-deterministic by design. The whole idea of AI, of large language model, is that it's by design should answer something different from what you asked. So just to give you a classic example in when people explain how does it work, the idea is that you have similarity between stuff. So a king is like a queen because they are both royalty, but it's also not because they are of different genders. So there is a slider, which is like a temperature of the network, which adjusts how close we want to find things. So we adjust it to get an answer that the queen is like a king, but it's still different. Now, if we increase the temperature and we make it to find things that less similar, and we will ask, give me something like a king, we will not only get a result of a queen, we will also get a result of a princess, for example. It's farther away because it's a different level of royalty or whatever. If we adjust the temperature to be exactly the same thing, if we will ask for something like a king, we will only get the king, because that's like the entire similar thing. So by definition, if we want to get results which are different from exactly what we asked, we have to give it freedom to generate different stuff. So for the same prompt, we can get slightly different results. Funny story about this particular illustration. No LLM model known to me is capable of drawing an upside down funnel. I don't know why. I've been trying for at least a year. Last attempt was last night, and it cannot. It will generate a funnel with the wide thing up and the narrow thing down, and claim that it is like this. And no matter how many efforts I put into it, it is impossible. I don't know what it means about AI or neural networks,
You're in the
but
southern hemisphere. You're in the southern hemisphere.
well, yes. So it doesn't work in both. I hoped that once I'm in down under, it will naturally make it the other way around, but it did not. Yeah, I don't know what it means. It's an interesting question. Right. So anyway, now you know the infinite monkeys theorem. I just did the curse of knowledge. I assume that everybody know it because I know it. Did you know this? So I'm going to explain it. What it actually means, what the theorem is, an infinite number of monkeys given an infinite time and infinite number of typewriters will eventually write Shakespeare poems. Because randomness, eventually it will create Shakespeare. Now, the funny thing is, considering the stochastic systems of our AI, that it is exactly what we have with AI, right? It's skewed a little bit towards sense, and it will give the right answer faster than just random generation of text. It will produce the correct code more frequently than just randomness. But in the end of the day, the fact that we are talking about stochastic systems means that there is a lot of variability. Sometimes it will get it right, sometimes it will get it wrong, and that's the problem. We gave them GPUs instead of typewriters, but the idea is exactly the same. Now, what can possibly go wrong, right? What we can do with it? First of all, you know, we have code reviews. Code reviews are there to ensure that the generated code, either by human monkeys or by AI monkeys, is verified by someone else, and then kind of we know for a fact that it's better. Now, the code reviews have what I call the looks good to me syndrome. And it's for various reasons. We're all busy. Doing code reviews requires context shift. We have context switch. We hate context switch. And another thing that we hate is reading other people's code. That includes our code, which is 6 months or older. We hate reading other people's code. And we obviously will hate reading generated code. Because generated code has no intrinsic value. Generated human code is a piece of creation. Someone put an effort into writing this code. And we, as our fellow developers, respect that and value that. AI-generated code has no intrinsic value. No one put an effort into writing it. It is valueless for us. It's worthless. And putting now our time, instead of doing our job, into reading machine-generated code is not going to happen. So next thing we know, looks good to me on any pull request. And this defeats the entire purpose of this guardrail. So not only we get garbage generated because monkeys, we also don't really read through it to begin with because it's garbage. And then it just goes to production as it is, which is a terrible idea. Yes?
Whether or not we're using an AI to do it, we have a professional responsibility to make sure the code is correct.
Yes, so that's a good observation. Regardless of who generates the code, we have the professional responsibility to review this code. This is our job, which is very, very true. Now, it all comes down to incentives and disciplines. right? So, hey, we need to review this code is important incentive, but hey, my colleague wrote this code, and I respect them and they deserve my review is much more significant incentive. And since we have a conflict of what we are doing right now and our incentive to do our, like, writing our code, and the other incentive of, hey, we need to review someone else's code, the other incentive should be very, very heavy. And a professional courtesy to our colleague have much more chance of getting our attention than just a bunch of auto-generated code. Well, yes, in theory, we should review auto-generated code as well. In practice, it will get more looks good to me than not AI-generated code.
Isn't it the other way? Because like the implicit bias is you don't really trust the machine, and you go in going, it's going to give you a bunch of garbage.
Yes.
I need to be a lot more vigilant.
That's a very good observation, that, hey, we assume the code to be worse, so we need to pay more attention to code that it's worse than to code of our colleague that we kind of trust and assume that its code is good. Yes, this is also true. But in the end of the day, the question is, what do you sacrifice? Yeah, I mean, the code reviews work. The problem is the percentage of, well, I think it looks okay versus I really read through it. And it's a range. It's not that now code reviews are absolutely pointless and we never look at other people's code. It is. But in the end of the day, the question is, what is the quality of our reviews? And I think that's another interesting data point to add to my research chapter is how AI-generated code affects the quality of the code review. That's an interesting question to look into some research into it. It's a good point. Okay, yeah.
So you're also injecting sort of like value positions around code generated by AI versus human.
Mm-hmm.
So if you treat it both the same in terms of respecting it, then well, you should be. My point is, you should be changing. You shouldn't be judging it based on what's changed.
Yes, you shouldn't be judging the code by how it was created. But that's, again, and I mentioned it, that's not how our mind operates, right? So we assign intrinsic value for something that was created by humans. And we don't assign the same value to something that was generated by the machine. It's not only about code. You can see the endless argument online about AI-created art, right? And there are a lot of people that will claim that AI-created art is absolutely worthless, not because how it looks or doesn't look, but because there is no artist behind it. It's the same idea. It's the idea of the end result. It's not only judged by itself, but it's, for us, it's also judged by what we know about the process that creates it. And it's true for art, it's true for code, which we all kind of say to ourselves that it's an art. No one else believes us, but we keep telling ourselves, yeah. So yeah. So basically, right. So AI coding agents do this to software quality, and again, the research kind of proves it. And I think we all know it by trying it. We know that the software quality that generated by AI is not great. So what can we do about that? What if we could somehow verify that the end code that we have is exactly what we asked it to do to begin with? That would be nice. Let's see if it's possible. This is what I call the intent integrity chain. Let's see how can we build this chain of trust from intent all the way to the code. Now, if only there was a way to ensure that code does what it expects to do, it is tests. Thank you very much, of course, right? So tests are our guardrails, and they can also be guardrails for monkeys. We write the test first, and then we let LLM implement the code, and then if the test passed, the intent is captured correctly. That's pretty obvious. We can then look at the quality of the code that was generated to pass the test. It might be great, it might be terrible. We might want code reviews to ensure that this code is better, but the intent is captured if the test passes, right? It's pretty obvious. This looks like test-driven development, which has its own like a comeback moment now with AI. There is a lot of talk about test-driven development with AI because of exactly this reason. Now, the question is who writes the tests? And obviously, I mean, developers should probably write the tests, but developers are not the ones who set up what the software should do, right? We started with that. There is product people and business people who decide what the product should do. Will they write tests? Probably not. Because they are not technical people, so they won't write tests. Now, if developers end up writing tests, we still have the chasm, right? So software definition documents written by non-technical people in plain English or whatever language, and then something, 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 and then developers are expected to write the tests that described what in the software definition documents, and then LLM generates code to fulfill the tests. Now, this is still our chasm because the misunderstanding comes here. Now, there is also another problem. And the problem is developers don't really do test-driven development. And developers don't do test-driven development for various reasons. One of the reasons is we are based for action. When we think about the problem, most of us, I know I do, I think about the happy path to solve the problem. I have an algorithm in mind. What code should I write that will do the thing that I want it to do? What I don't think about is how the test will look like, how the exceptions will look like, and everything else. Because we already know how to solve the problem. What we want to do is not writing tests, is actually writing the solution to the problem. So this is, sorry. So this is one of the reasons why we don't write tests before code. Now, there is also another problem in TDD writing the tests and not writing the code. I will get to it a little bit later because it's true for other stuff as well. So, okay, so here is the problem. TDD doesn't work without AI, and probably TDD won't take now, and we see that it's not, the world by storm now with AI as well. And we still have the chasm problem that we want the technical people to define what software does, and tests is not that. But what if it almost won't look like code? What if we're going to write specifications in English or other human language, and then people and product and business people can actually read and write it? That looks like,
Specification by design.
yep, that's BDD, right? Behavior-driven design or specification-driven design, or someone mentioned Cucumber. That's exactly that. Now, how is this going in the observable universe? Not great. And that's because business and product people are creative natures. They want to write the software definition documents in their own language. They have some structure, but in the end of the day, what goes inside is, let's describe the software and what's not. The structured spec is a little bit too structured. So we end up with developers writing the specs. And that means that we still have the chasm. So there are like a very abstract software definition documents that are read by our business people, and then something, and then the developers write the specs, and then the tests are generated from specs in Cucumber and what's not, and then LLM generates the code to the spec. we still have the chasm that people who write the software definition documents and the people who understand them and then write specs are different people with the intent to prompt chasm. And developers don't like BDD, even less than they like test-driven development. If developers had to write tests, code, you can only imagine how much they hate to write specs, which is not code. So yeah, we still have the same problem. What we can do, we have a great tool of generating text. It's called GPT and LLMs in general. So how about let's do the LLMs to do the work. We have the software definition documents, which are now written by product and business, but they are now our prompt. And then LLM creates the spec in the structured language of Cucumber and what's not. And then, this is very important, since everybody can read the spec as it is almost plainly English, the people who wrote software definition documents can actually read, understand, and agree on the spec. Now, once everybody agreed on the spec, we can let LLM generate the tests from the specs, and then let LLM implement the tests until they pass. That sounds like a good idea, right? Well, yes, but no, because monkeys. Right? We cannot trust monkeys in doing the chain because they will skew the chain for whatever end result they create. So once we let them generate the tests from the spec, tests can be completely off. And once we let them implement the code to pass the tests, they can change the tests to match the code and not the other way around. We cannot trust the monkeys, and that's exactly the problem. Let's see how we can solve that. Now, here is the list of our chain in terms of artifacts produced. So we have the prompt, it's created by humans, and that means it cannot be trusted because humans are also monkeys, we cannot trust them as well. And then we have the spec, that it's generated by LLMs, by the monkeys, which means that we cannot trust it. And then we have the test, which generates by the monkeys, which means that we cannot be trusted. And then we have the code that generated by the monkeys, which means that we cannot trust it. It's not a great intent integrity chain if we cannot trust any of the steps, is it? Let's see what we can do with it. Yeah, not great. How can we solve it? We can replace monkeys with algorithms wherever possible. So for example, test generation. Test generation, as I mentioned, is something that in our first idea is generated by monkeys, which means we cannot trust it. The tests can be completely different from what the spec actually said that it should be. So how about we remove the monkey and we actually trust an algorithmic run of executable specifications. Cucumber, as someone mentioned, is a great example of exactly that. With Cucumber, the specs are expressed in an executable language. And then we don't need the monkeys to generate the code, the tests, because we can just run the specs to verify it, and then this is solved. No monkeys in the picture anymore. Another problem is prevent monkeys from messing with validation. Now, if you ever asked AI to write tests for a certain code, there is a very good chance that it made the tests to match a code which have bugs. Now, TDD in the naive form of AI doesn't really help, because if you write the tests or ask AI generate the tests and then ask AI to implement those tests, it will change the tests as much as it changes the code. So it doesn't really verify anything if it can match the test to the code and the code to the test. So generated code by the monkeys is also a problem because it will change the tests. What we can do, we can lock the tests away. So once we have spec or tests which we know for sure that express our intent, we just make them read-only. And it can be as easy as making the files actually read-only on the operating system. There are IDEs that can prevent AI from touching certain folders or like a certain directory structure or file types, and we can do it with those IDEs as well, or those AI tools. But the simplest way is just changing the files to be read-only, and then we protect them. So now the code is protected, the test is protected, which we are making progress. Now for everything else, this is Ronald Reagan, this is Mikhail Gorbachev, and the year is 1988. They meet in Reykjavik to discover nuclear disarmament, and Reagan says, "Доверяй, но проверяй." My Bulgarian friends are smiling because they probably understood it. For everybody else, what he said in Russian was trust by verify. And that was about, yes, we trust you, dear Soviet Union, in nuclear disarmament. Sure, of course, because why not? But we will send some people to watch over you. And that's exactly what we need to do. We need to trust by verify for everything else. So how do we do that? We have a prompt that is created by humans. It definitely should be verified by other humans. We have a lot of stakeholders that need to look at this prompt, at the software definition documents as we defined it, and agree that this captured our intent. This is the software that we want to get. And then the specs are generated by monkeys, but they are human readable. Once the specs are generated, everybody go back, the same people who are all the stakeholders, and check that what we have there is what the original intent was. There are two types of things that can be discovered. First, human misunderstanding. We wrote the prompt in a way that when even directly understood, the spec is not what we actually intended. Just because English language or other language is not perfect to express software requirements. And then we can go back to the prompt and edit it, or just edit the specs directly and do the adjustments that we want. Another problem, monkeys screw up. They understand something from the prompt and generated something in the spec that was clearly not what we wanted. And then again, we do the same process. Now, there is no difference in those two. Whether we didn't express ourselves correctly or the model didn't understand us, it doesn't really matter. This is the intent to prompt chasm that we are bridging with this review. And then the test, there is no problem. It's generated by algorithm, or we just run the specs, so there is no need to verify additionally. And the code is generated by monkeys, but again, because the tests or the spec are protected, we can trust the process to actually generate what we want. So now, we don't have any problem in business people needing to read the test and the codes because there are no monkeys involved, and we can trust the problem because it's verified by the machine as well. So here we go, intent integrity chain. Software definition documents are prompts. Now, because we can run them multiple times, they are actually living documentation. They are exactly what we get in the end of the day because they are the part of the process and not just some documents lying somewhere in Google Drive that no one will ever read again. LLM creates the specs. Everybody read the specs and approve and go back to the prompt if it's not what they actually meant it to be. And then from there, no more human reading necessary. Algorithm generate the tests, or we can just run the spec, and then LLMs read implement the read-only tests until it passes. And this is how you make sure that whatever there is in the end is exactly what we asked to begin with. And that's the nice thing about it. So everybody write text, specs are reviewed by all because that's still English or other human language, and then software definition documents, now we know that they are the specs and they are living documents. And everything else is derived from the specs automatically, and we don't need to read the test or write the test or do any of that. And all code is verified by machines without trusting monkeys or humans for that purpose. And I think that intent integrity chain is what BDD was supposed to be, right? It was meant to be. We define and agree on intent, and then we verified everything that AI does, either human review or automatic, and then we don't trust AI we don't verify because it's all algorithmic from there. And the question is, okay, I mentioned Gherkin and Cucumber. They are done, 2 more minutes. And you're late, so yeah, I'm almost done. Yeah, Gherkin and Cucumber are old, like 20 years old. Are they fit for this AI-centric process? Maybe yes, maybe no, right? It's good for defining behavior. It is human understandable and machine parsable. That's exactly what I want from the specs. And it's proven and it works. BDD is a thing, although not very popular, but there are a lot of adepts that believe in that and do it, and it works. There are downsides. For example, non-behavioral constraints are hard to describe in the format of given when then. It's doable, it's not very hard. Now, the good news are that the better specking for writing the spec tools emerge right now. The spec-driven AI is all the rage. Every month, there is new framework that is coming that sits exactly in this part of how do we define the spec from the prompt and then run it automatically by AI. So for example, the GitHub spec kit. GitHub spec-driven development, flip the script of traditional software development. You don't say. And then they do exactly what we just spoke. So we can install it, and this is very much like Gherkin and Cucumber, spec-driven implementation, which is exactly sits in this part that we're talking about. Kiro. Kiro is an IDE created by Amazon to do exactly that. They generate the specs from the prompt, and then you can generate the tests from the spec and do exactly that. So there is another part here that might potentially replace Gherkin and Cucumber combination. Tessel. Tessel is a startup that started with exactly the same idea. How do we make the spec and the AI code and maintains it? And then they changed a little bit to providing specs for third-party libraries. How do AI understands what Spring Boot really is? The question that we kind of started with, and this is something that Tessel does now, but it's still very, very related. So, by the words of Andrei Karpathy, the hottest new programming language is English, and this is what the intent integrity check is about. We define what software should do in English. We read the generated specs in English or any other language, and this is our programming language. Everything else derived from there automatically, and the code is now interim language. It's like the Java class, what's called? I forgot the term. No, the code that we compile into. The bytecode, thank you, yeah. So now the code is bytecode. It's an interim language that is going to be translated to even lower and lower layers, but our coding language is now English. So intent integrity chain generates consensus. Features are verifiable back to the requirements. We can start trusting AI more, and there is still work to be done. With that, Ej Baruch, talk to me about tax care and about end-of-life maintenance of your libraries. This is ChurConf. Use the hashtag. We're going to take social media by storm with so much of us speaking about that. And intent integrity chain is the hash code that I invented. Let's see where this goes. Shownotes.taxcare.com. This is where you go for the slides, the video, all the links. And now I can tell you, there is a raffle that you can win like a vintage, very nice vintage keyboard for when you write your software definition documents. No one is going to write code after this. And you can scan this QR code, go there, fill the form for the raffle. And as I mentioned, I have tons of t-shirts. We'll be happy to hand them over to you. With that, thank you very much.
Thank you, Mark, for the very interesting talk. So now we'll